I'm here with my colleague, also is co-author of this work, the importance of online analytics to protect the fragile aquatic environment. I think before it was a good introduction of the situation going in the direction of water. Sure. So when we think about fragile aquatic ecosystems, such as natural environments, no, and with the let's say, with high sensitivity to external disturbances. So depending on the resilience on the environment, it can recover, for example, from an impact of, let's say, wastewater contamination or something, or if not, it can be damaged permanently. So if we think here in the Cuatro Ciénegas, what's the situation with the wastewater? This is a community, a small community, relatively small community, and what happened with the wastewater of Cuatro Ciénegas. So I have to say, now I'm coming from a company, it's called, it's an engineering company, it's Servicios de Ingeniería and Control Avanzado. However, before I was working at the Mexican Institute for Water Technology, and I had the luck and the opportunity to come here last year to run to do a study on wastewater, what's the situation of the wastewater here at Cuatro Ciénegas. We did also some quantification of flow rates of wastewater, and as well as we did some water quality analysis. So what we found, it was that wastewater is going to those ponds, which are here, are actually some ponds which are not, let's say, with good engineered, no? Just the wastewater is dumped there. And we found also for this, we received a lot of support from CONAM and also the local authorities. We found that there are three main collectors of wastewater. One is coming from the old town, we call it Punto Benito, because the street is Benito Juárez, so it's coming from a street named Benito Juárez, and it's going to those ponds here, these two ponds. On the other hand, the new part of Cuatro Ciénegas, more to the south, no, they have two collectors. We call it Punto Centro. One of these collectors was visible to, I mean, we could see the wastewater and the collector, but the other one, it was more deep into the ground, so we could not see the wastewater. So we have three, and our concern at that time, it was first to characterize these collectors from the perspective of how much water is being generated by the city. And what we also found is that nearby to these collectors, where there are raw wastewater, this is raw wastewater from points 1 and 2, there is close by fresh water from the Ciénega. This fresh water from the Ciénega is coming from a place some kilometers far, but is being transported for irrigation purposes. So the risk of getting contaminated, this freshwater body, is very high because it's probably maybe not more than 10 meters far from these collectors. So one of the activities we did, it was to, as I said, to characterize wastewater, so to basically measure flow rates based on typical velocity approach, and also with the cross-section of the channel, we could quantify flow rates. We also took samples, some physical-chemical parameters were determined on site, no? And some others, we have to transport it to the laboratory and analyze them there. Yeah, so here are some of my former colleagues doing this work. This is Punto Benito. We have performed this characterization according to the normativity, the Mexican normativity, which says that we have to sample at different hours per day. So that's why we also did a sampling during the night. And some of the results we found of last year, this is March 2024. Here are selected results. Those without the asterisks are mean values of the 24 hours campaign we performed last year. And here with asterisk is all measurements, punctual measurements at 11 a.m. What we found here is interesting. It was the electrical conductivity, which is atypical to conventional, let's say, or typical electrical conductivity of normal, let's say, or typical wastewater, which indicates us that the base ground of electrical conductivity was probably high, but we could confirm also measuring the electrical conductivity from the tap water. And this is probably because of the geological situation here. We have salts, accumulation of salts during maybe a lot of years, and which has increased electrical conductivity. Apart of that, the rest of the parameters are quite typical to normal wastewater, domestic wastewater, let's say. And we could also, when we see the ratio between BOD and COD, sorry, this is in Spanish, yeah, we found a ratio of 0.4 at both places that we sampled, which indicate that the water has the potential to be biologically degraded. So in this sense, we can say that the biological wastewater treatment plant could be a good option for treating the wastewater of Cuatro Ciénegas. Yeah, concerning the flow rates, we from both points we found a mean value of 6.6 liters per second at Punto Benito and 13.8 liters per second at Punto Centro. Knowing that the other point could not be characterized, we expect that probably the same amount is coming to the point 2. So how to protect these fragile aquatic environments, for example, against wastewater contamination, what could be the effect on organisms or on the ecosystem in general. So one of the key points is wastewater treatment. Of course, this is very important. But another point is monitoring. We remember the COVID time. It was said that monitoring or measuring is very important. We have to measure as much as possible to understand what's happening. And here is similar. If we measure what's happening in the Ciénega and what's happening with the wastewater, we'll have information for taking decisions on what to do. So online monitoring, they will say what parameters. Probably you know that recently a new legislation entered into force. Well, it's the same legislation, but it was updated 2021. It establishes the maximum limits of selected wastewater parameters to be discharged into natural bodies in Mexico. So from these parameters, some parameters were added into the norm, some of them were took out of the norm. But we identify 2 new ones. We have the total organic carbon. Total organic carbon must be measured when the concentration of chlorides exceed 1,000 milligrams per liter in water samples. And toxicity. Toxicity is a new parameter that was incorporated into the norm, and since it has to be measured, it must be measured now. So total organic carbon. Going in the direction of measuring online total organic carbon. We know total carbon is the sum of total organic carbon plus total inorganic carbon. Total inorganic carbon coming from carbonates, CO2 dissolved in water forming carbonic acid. Then we have carbonates and bicarbonates. Total inorganic carbon, total organic carbon, all chemicals containing CH bondings, which is which express or tell us an amount of any organic pollution in a sample. And here is where we enter as an engineering company, as SICA Medición. So we actually are, let's say, capable to measure this compound, this online, using state-of-the-art technology. These are German machines, and basically what they do, this is called QuickTalk Ultra. And this is an online analyzer, process online analyzer, where we measure total organic carbon. How it works, the measurement principle is here. Let's say if we see the points 1, 2, and 3. First is taking the sample, second is the combustion of the sample, and then measurement. We can configure these analyzers to have from 1 up to 6 streams, and by Bringing the sample using peristaltic pumps, it goes to these vessels, and from these vessels we have here a robotic arm. This robotic arm is taking the samples, is what's here, and depending on the configuration of the analyzer, we inject directly the sample into an oven at 1200 degrees Celsius. If we have inorganic carbon in the sample, we have to get rid of the inorganic carbon. For this we use what we call it a thick reactor. So basically we reduce the pH, we bring all carbonates and bicarbonates to CO2, and we did a stripping. This stripping the CO2 from the TIC reactor can be measured, no? Or not, depending on how is the profile of the water, let's say. And then the sample is injected into the oven. Organics in the sample, you can imagine at this temperature, a small quantity of a sample, approximately 80 microliters, is when it enters into the oven, is converted into a 3.2 liters of gas, which contains CO2 formed after the oxidation of the organics. And this CO2 is brought into a detector, non-dispersive infrared detector, for measuring the CO2. And by doing typical calibration curves, where we have a known concentration of TOC, we inject it and we detect the signal, we can create calibration curves and find TOC. And this can be all controlled in a computer, when we can program and just measure online this parameter. Measuring online, for example, compared to discrete sampling, so we have here some points, discrete sampling, measuring online will allow us to also see what's happening in between, and measuring quite fast. So these are some examples of what we do at the engineering company. So we install actually these online analyzers for different applications. We do all the engineering, startup, commissioning, maintenance, calibrations. And on the other hand, talking about toxicity, which is the other new parameter added into the Mexican norm. So we understand toxicity as a direct harmful effect on organisms, which depends on time, exposure, and dose of a substance pollutant. I was giving this example, what could be the effect of this sewage if it reaches the fragile aquatic ecosystem. So we see here typical dose concentration curves, and bringing this knowledge into an online analyzer and state-of-the-art technology for measuring toxicity, we have this process analyzer is called Tox Alarm for measuring toxicity. One of the characteristics of this analyzer is that self-generate bacteria culture. So in this reactor, nitrifying bacteria is being cultured and is self-regenerated, so which means it must have a nutrient solution, so with ammonia and so, and also constant aeration. In this reactor, what we do is that here are the bacteria, they are growing the bacteria, and here what we call it the measurement cell. Here is a peristaltic pump, and a sample of the culture is going to the measurement cell, and we measure the dissolved oxygen, typically dissolved oxygen measurements. So which means if here, as we have saturation of oxygen because of this is permanently aerated, if here is not aerated anymore, so which means that the consumption of oxygen will decrease. And if the dissolved oxygen decreases, that means that the bacteria are alive. However, what we do is that we put a sample, here a sample where a suspected toxicant, and we put in contact the sample with a fraction of the bacteria into this cell, and if there is a toxic effect on the bacteria, then the concentration of dissolved oxygen will not decrease, and then we say, okay, there is a toxic effect coming from this sample. From where is coming this toxic effect, we don't know. It's not selective, let's say. So these are some examples, a little bit more into detail. We have here an stirrer, magnetic stirrer. This is the measurement cell, dissolved oxygen cell. Here we see this stone, porous stone for bringing the air into the analyzer. Here are some examples. This is the analyzer ready to be packed. They say this is process online analyzer, so we can measure toxicity measurements every 2 minutes. However, okay, we are in one sense dependent or limited that the organism we use for measuring are nitrifying bacteria. Here is how it looks, the software. When we do, for example, add nucleophile culture into the measurement cell, you see the consumption of, let's say, the decrease of the dissolved oxygen concentration, you know, because of due to the respiration of the bacteria. Yeah, now I would like to give the microphone to my colleague so that he also can tell us a little bit about what we do for laboratory analysis.
Yeah, thank you. We have seen the inline solutions for different analytes. For example, in this way, I want to show you the equipment for lab. Behind every story, the tool of analysis. What do we do when we make an study? No? Well, we have the equipment. For example, we need to increase our robustness of the analysis, ensure repeatability results, and expand our data with expand the number of analyses to obtain more meaningful results, and save analytical time. Save time in the analytical process. Why? Because maybe we want to spend this time to make an article or make to prepare an sponsor or something else. Here you can see the equipment for toxicity on the lab. We have equipment for oxygen demand, pH, and conductivity parameters not in the lab. And another parameters that we can measure is anions, cations, and no ionic parameters that maybe can affect our studies. How can I select the best instrument for our investigation? For example, we are the providers, but we always, when you ask for us for an application, we always ask about how many samples do you are going to measure. For example, here you can see the SmartChem 200 to 600, that you can measure different volume of samples. For example, 200 per hour and 600 per hour. And it depends if you need to analyze 20 samples per day, or maybe to 80 samples, or to 100 to 200 samples. And it depends the type of analysis that you need to measure. For example, if you need to measure in wastewater, in seawater, and environmental variables, maybe you want to measure alkalides, alkalinity, ammonia, boron, bromide, chlorine, chloride, some type of sample of different matrix, for example, soil and plants. What about the toxicity equipment? Maybe we know that the normative have different applications that we can follow for our studies. For example, the MX 112 to analyze the toxicity on water. Well, how it works, the instrument. For example, the instrument uses a bacteria that have a luminosity to see the effect of the toxicity. This bacteria is from some marine. It's a marine bacteria, and well, you can see as less luminosity, the toxicity is higher, for example. That's it.
Thank you, Horacio. So, yeah, going to the end of the presentation, what we also want to show you is at SICA, we have done mobile laboratories, depending on the application. They can be very complex. They can hold laboratory analyzers and be moved everywhere for sampling, but also we can arm these containers with process online analyzers, as well as building new laboratories. We have done that already. It's also part of the services we offer. So next slide, please. So yeah, this is going to the end, and many people to thank, and also to say that well, at SICA we also offer. Now we focus the presentation on water, but we also sell solutions for measurement gases, pure gases, like for what we see on the top is a mass spectrometer for laboratory. We have also for online applications. That one here is for pure water applications like pharma industry. That's for measuring oxygen. And yeah, so with this, I'd like to thank you. And my colleague want to say also something with, if you make a question, we have a gift for you.